Right, number one there. A company designs spinning toys using the family of functions y equals cx is a constant, some positive constant x times square root 4 minus x squared. This is the graph of this one. Y equals c times x square root 4 minus x squared.
Mm.
When you see it over here, when x equals 0, y equals 0, right?
Yeah.
Over here, this time 0 is when x equals 2, 4 minus 2 squared is 4, still 0, okay? So this is 2. Okay, you can see that over here, okay? Okay, the figure above shows the region in the first quadrant bounded by the x-axis, and the graph of y equals this one, okay? And this is some value which we don't know what is the value we see. Each spinning toy is in the shape of solid generated when such a region is revolved about what x-axis. Okay, around
Yeah.
we're gonna find okay spinning toy in the shape of solid. Okay, here. Okay, revolved about this one. So the other side looks like this way. Okay, revolved means what they make circle, isn't it? It looks like this way. Both x and y measured in inches. Okay. Find the area of the region in the first quadrant bounded by x-axis and the graph of this one. Okay. Yeah. Before we make rotations, we're gonna find out area of this one first. Okay. How can you find the area of this one? Take an integral, right? Take an integral. From where? From 0 to 2. From here is the bottom is y equals 0. This is top. Top minus 0, y equals 0 is nothing, okay? We take integral this length. Integral from 0 to 2 up to 2 over here, right? Follow this graph. So 0 to 2, c to the x, but they use the c is 6 now, okay? C is 6. So 6x, you can use 6 out. 6x and square root 4 minus x squared and dx.
Yeah.
Okay? So we're gonna
Mm.
find this without using calculator, okay? So I think we need a little some space there. I'm gonna make it small. I better use this space up there. Okay, that's the first one. Take integral this one from 0 to 2 x times 4 minus x squared and dx. Okay, how can you find this one? This is actually what u substitution, right? Inside, when you take a derivative, you're gonna use what negative 2x, but still x there. Okay, this one we have to use u substitution. Which one is u? U equals what 4 minus x squared, right? From here, du equals how much? Negative 2x dx. You can see that x is there. Okay, only x is a variable. X dx is what equals to when you divide by negative 2 over here, du over negative 2, right? This is a definite integral. We're going to change all this x value to the u value. Okay, take u, change all u value. When x equals 0, y is 4, right? U is what? 4 minus 0 squared 0, that's u value is 4. When x is 2, what is the u value? Well, 4 minus 2 squared is 0, right? It's going to be 4 to the 0, okay?
Mm.
After that, x dx is what? Negative du over negative 2, right? That is x dx. And inside is what? Square root of u function, okay? That's it. But this negative 2 move to the front, right? 6 divided by negative 2 is what? Negative 3. Are you okay with this?
Yeah.
6 times divided by negative 2 is what? Negative 3. Take integral from 0 to 4. U is what? U 1/2 of it, right? du, isn't it?
Yeah.
Now take integral. Antiderivative of u to the 1f is what? Plus 1 is u to the 3 over 2. We divided by u 3 over 2 by its reciprocal 2 over 3 times. That's the antiderivative. You still have a negative 3 there, okay? Now take our integral from 4 to 0. So negative 3 over here. Inside the u equals 0, that is 2 over 3, u 0 is what? Nothing, 0. Minus 2 over 3, now u is 4 there, okay? U is 4 over here. 4 is what? 2 squared, but over here 3 over 2. How much is one? Negative 3. 0 is nothing, negative 2 over 3. 2 squared, 2 is cancelled out, 2 to 3 is what? 8. So negative 3 times negative 2 is a positive 6, or you can cancel out this one. Negative 3, this one negative 3 cancel out. So 2 times 8 is what? 16. Is it okay? So this area on the curve is 16 is the answer, okay? That is just 16. Okay, I better use, okay, split this one. I need a new, okay. That is better for me, okay. That's the question. Okay, the number B, it is known that y equals cx square root 4 minus x squared. So dy dx is given by over here. So that's B. Dy dx is equals to what? C 4 minus 2x squared over square root 4 minus x squared. They gave this already. Okay. Now we can save time. For a particular spinning toy, the radius of largest cross-sectional circular slice is, okay, radius, that is what? Largest cross one, okay? 1.2 inches. What is the value of C for this spinning toy? So we're gonna find out the maximum value, right? The largest sectional circular slice is 1.2 inches. We're gonna find the maximum value, okay? Is it okay? Yeah, that's the derivative over here. Okay, to have find the maximum largest value of x. This is x. X is a radius. Let me see. This is positive by the x-axis. The radius of largest cross-sectional circular slice is 1 point. Okay, when you make right cross-section over here, okay. Some value of x. Okay, this one. Some value of x. The radius is 1.2. What is the value of c? Okay. Let me see. Why is it radius but the x is not radius?
We can find it through hold on.
Anyway, to find the maximum value of c, right? Dy dx is what?
C times the whole thing.
Yeah.
And then
The
Simplify.
highest point over here, right? We're gonna find the highest point, okay?
Okay.
This is not the value, it's a little bit different story. Remember, take this one, height of this, take the radius, okay? This is radius, x. Okay, you're gonna find the maximum over here, right? At this time, slope is 0, isn't it? So dy dx is given, equals to 0. But denominator cannot be 0. Numerator only cannot be 0, right? Numerator only 0, right? So c times 4 minus 2x squared must be equal to 0. But c cannot be 0, right? Some positive constant over here. Positive constant. C cannot be 0. Inside should be 0, okay? So 2x squared equals to 4, isn't it? So x squared is 2. X equals 2. And x equals what? Square root 2, right? And that is the value of C. No. X equals square root 2, right? Yeah, okay. Oh, there's a confused. X equals, we just find out, okay, at this point, x equals square root 2. This is the radius, okay? When you make turn around over here. Okay? Radius, isn't it? Right, that's right. We're gonna find this value, right? That is radius, okay? We're gonna find this one. But they set the x value of a computer. Anyway, we're gonna call. When x equals square root 2, it has a maximum over here, right? Highest point. So this is the radius. So put this number into the what? Here again. It's okay?
Yeah.
Right? We're gonna find this y is the radius, okay? So that's why the area of this square is what? Pi y squared, isn't it? Okay. Now put this number x is square root 2, but this at this value of the square root 2, that is the maximum, okay? Put this number there. So we're gonna find the y there. Y is what? C, x is the square root 2, and 4 over here. 4 minus square root 2 square is 2, right?
Yeah.
This maximum radius is, they gave it this already, I think. Radius is 1.2 inches, right? Yeah, this one equals 1.2 inches. Are you okay with this?
Yeah.
Yeah. This is y, okay? The maximum y. Now let's find the value. This is the correct answer, I think. Not x value, okay? So this one is what? C square root 2, and 4 minus another square root 2, right? So this square root 2 times square root is positive 2. So 2c equals 1.2. From here we can find what the value of c is what? 0.6. Okay? Yeah. I think that is correct. Okay? That's the number 2 over here, okay? Alright, number 3. For another spinning toy, the volume is what? 2 pi cubic inches. Okay, volume is 2 pi cubic inches. What is the volume of C for this spinning toy? The volume is 2 pi, okay? Now let's find the volume over here. How can you find the volume? From here, right, the pi y square, right? That is the area, isn't it? Yeah. So we're gonna take integral from 0 to up to 2, right?
Yeah.
So times pi r square y square. Okay, pi y square. Y square, where is the y? It's over here. Cx. And the square root 4 minus x squared, that is y, okay? That's y, that's the radius. And square, and take the integral from 0 to 2. That's the volume, okay? This volume equals to 2 pi. From here, we're going to find the value of C again. This is true, right? This is the question, I think. Okay, now we're going to find this one. What, this one, there's a lot of work.
Yeah.
Pi times 0 to 2. The square is what? C square, x squared. Inside the radical is out 4 minus x squared and dx. Okay?
Yeah.
Now let's find this one. Pi over here, 0 to 2. 4 times c squared is what? 4c squared x squared, right? and x squared times a c squared x squared, another x squared c squared times x to the fourth power, okay?
Yeah.
That's the value. Now find antiderivative, this one. So x is a variable, okay? C is a constant. So plus 3 divided by 3 is what? Antiderivative. Pi is out. Inside antiderivative, 4 over 3 c squared x cubed, isn't it? Are you okay with this? This is plus 1 divided by 3 of there, okay? Second, plus 1 is what? X to the 5 divided by 5, okay? That's the second one, antiderivative. We take integral from 0 to 2. So pi over here. 4 over 3 c squared, x is 2 cube is 8. This number is 8. So 8 times 4 is what? 32 over 3 c squared, right?
Yeah.
Minus c squared, this is what? 2 to the p squared, still 32, right? Still 32 c squared over 5. After that, put this number 0, x, alright? X is 0, they're all 0, okay? Nothing. Now simplify this one. Ah, this is a lot of work. Common denominator is what? 3 and 5 is 15, okay? You times 5 to the first one. 32 times 5 is 160 c squared. The next one, 3 times 32 is 96 c squared. It's okay? This is how much? Pi times 160 minus 96. 64, right? 64 c squared over 15. That is equals to, where is a 2 pi cubed, right? That's the value of 2 pi. Are you okay with this?
Yeah.
So using this one, we can find the value of c. Okay, pi is cancelled out. So times 15 both sides. Now you got this one. 64 c squared is what? Times 15 times 15 is 30. So c squared is equals to how much? 30 over 64, right?
Yeah.
When you divide by, simplify this one, 15 over 32. So c equals to what? A positive number. C cannot be negative, okay? Positive square root 15 over 32. You can leave it this way. You don't have to simplify, okay? In calculus, that's fine. It's okay?
Yeah.
Or you can use this is already square root. This is already a square number, okay? C equals what is that? 8 over square root 30 is okay too. It's okay?
Yeah.
You can use this way or this way. Both will be okay. Yeah, that is number 3, okay? This is a spinning toy, okay? Looks like this was spinning toy. It's okay? So actually, when you play it over a spinning toy, looks like this way. Okay? So how about the number 3? Is this understandable? Is it okay?
Yeah, it's making sense.
All right. Okay. Now we're going to next question. So number 4 there, okay? This to take. This. F with the continuous functions. Yeah, they are all continuous, right? They are not discontinued, okay? Just piecewise functions with linear, okay?
Okay.
All right, consisting of 4 line segments. And g is the function defined. We create a new function of g of x. G of x equals what? 0 to the x ft dt, okay?
Okay.
This is f of x. It's the same graph about different t, okay? So that means what? Ft f of x, the same graph, okay?
Okay.
On what open intervals is the graph of g concave up? Concave up is, where is concave up?
One's positive.
What that
and
means?
it's around well, positive of course, but like on this one,
The second derivative is what? Positive, right?
yeah.
Okay. So where is the second derivative?
Mm, we can take the second derivative first.
Yeah. Take over here. This they said it's what? Graph of G, not graph of F. Okay? Graph of G is here, not graph. This is a graph of what? F of X graph or F of T graph. Okay? But we are talking about, right, concave of on this graph of G, right? So first, you can use, right, first derivative, okay? So G prime X, what is that? Take a dx, this one. dxd, take x f to dt, right? So this x move to the front into the t, right? It's okay? Then equals y f of x. So this f of x is what? Graph of what? G prime x. Are you okay with this?
Yeah.
G prime is not take log over here. Its slope is g second prime, right? G second prime x equals what? Slope of what? G prime x. So to have positive, right? This is concave of, isn't it? So slope of this G prime x is a positive. Slope of this, all the positive is okay? Slope is a positive, right? So
Yeah.
negative 4 to negative 2, slope is a positive. In these intervals, the graph of G of x is what? Concave up, right? Another one is this slope is negative, all the way negative, concave down. From here to here, slope is positive again, okay? And this one and another one is what? 2 to 6. It's okay?
Mm.
Slope of this fg prime always what? Positive, isn't it?
Yeah.
That's right. In this case, they are all what? Concave up, right? In this case, this g of x is concave up.
Yeah.
Okay? In the interval. Here and here, okay?
Yeah.
Number 8 is okay, right? But you gotta take right derivative, okay? You don't have to take right second time derivative, it's okay? Only using the first derivative because each slope is a second derivative, okay? So we can check it out, the slope is positive and negative. Slope is positive, the graph is concave up. Slope is negative, the graph is concave down, okay?
Yeah.
Number B is the function defined, another function they create, px equals what? At this time, g of x, another additional f of x. When you put this together, product, from here we're going to find the p prime 3. From here we're going to find the p prime 3, okay? P prime is a derivative. We're going to take a derivative of p there. Take a derivative p. What is it? First one prime times second. First one don't touch. Take second prime x. It's okay? That is the derivative of p prime x, okay? Now we need to find, okay, derivative at x equal 3, okay?
Okay.
At x equal 3 is, what is that? G prime 3, f3, g3, and f prime 3, okay? We got
Yeah.
this one. What is the value of g prime 3? G prime 3. This is a g prime x graph there. This is a g prime x graph or equals to f of x graph, but this is a g prime x graph. When x equals 3, what is g prime x? Here, right? Negative 3, isn't it?
Yeah.
This is a graph of g prime. So g prime 3, put this number x equals 3 there. Here is 3. This is a value of y is what? G prime 3, okay? This is a negative 3. Are you okay?
Yeah.
Where is f over 3? This also f over 3, right? G prime x graph, f over x is the same graph. Okay? So
Yeah.
f over 3 is still what? Negative 3, right? Are you okay with this?
Yeah.
Okay. The next is G prime 3 now. G prime 3. This is G prime. This was the G3. Different, okay? Antiderivative. So how can you find the G prime 3 here, right? Here is what G prime 3 is how much? From 0 to x equal 3, f of t dt, isn't it?
Yeah.
This is what? Sum of the areas of ft, this graph, from 0 to 3, 0 to 3, up to here, this area is equal to this sum g over 3, okay?
Yeah.
Okay, how can you find this area? When you take over here. You're gonna find up to 3, okay? Not 4, up to 3. From here to here, right? 1, this height is 4, this height is negative 4. This is a positive area, this is a negative area. It's gonna be as what? Same congruent triangles plus minus 0. This is sum of this area 0. We don't have to calculate.
Yeah.
Now find out this area, right? This area is what? 1 times 1, this is another 1, another 1, this is the half. 3.5, isn't it?
Yeah.
You can count it this way too, right? Or 1 times 3, after that small triangle, okay? 3.5. But it's going to be negative, right? Below the x-axis. So g over 3 equals what? Negative 3.5, okay? So f prime 3 is now how much? This is already f of x. F prime 3 is what? The derivative. It's a slope of this one, okay? We already f prime 3. F prime 3 up here. F prime 3, slope of this one is how much? Positive 1, right? Slope of this one is 1, isn't it? This is equals to 1, okay? So 3 times negative is a positive 9 minus 6.5. The answer is what? 5.5 is the answer, okay?
Yeah.
Number B is, I think it's okay, right? Okay, now the next one is number C. Find the limit value of here. Limit x close to 2, g of x, and x squared minus 2x. G of x over here. Can you see that? G of x. Now replace with this one. Limit x close to g of x, look like this one, 0 to x, f of t dt over x. I'm going to factor this, okay? Or it doesn't matter. X squared minus 2x. So what is the g of 2 over there? Can you see it over here? We're going to find, okay, g of x, okay? From 0 to, when you put this number, anyway, put this number 2 there, okay? We check it out. 2 there, that is 0. G over 2 is how much? Can you see the g over 2 there?
Yeah.
G over 2 is up here, right?
Yeah.
G over 2 is what? From here, 2 is what? F over 2, we count over this area, the other area, plus minus 0, okay? This is also 0, isn't it?
Yeah.
This is a 0 over 0 types. It's okay? Do you understand when you take what 0 to 2 ft area is what? Here, this area, the other area equal, right?
Yeah.
this area and the other area over here. Same triangle, right? Congruent triangle. This is positive area, this is negative area, plus minus 0. That's why this is x is 2, this is always 0, okay? So the limit value of this one is 0 over 0. Then we can use what? L'Hopital's rule there, okay? So put this number L'Hopital's rule. Limit x equals 2, the next take it prime, okay? G prime x. Denominator what? 2x minus 2. Are you okay with this?
Yeah.
Now g prime 2 is how much over there? G prime 2 there. Where is g prime over? This is the graph of g prime, right? G prime 2 over here. Negative 4, isn't it?
Yeah.
Is it okay? G prime 4 is negative 4. 2 over here, that is not anymore 0, okay? Just why we put this number in there. So 2 times 2 is 4, minus 2 is 2, right?
Yeah.
So limit value is negative 2. It's okay? That's the answer. This is L'Hopital's law, okay?
Okay.
All right, number D. Take a look at number D. Find the average rate of change, not average value, okay? Average rate of change is minus 4, 2. Change of G, right? G is G. On what? In this interval, negative 4 and 2, right?
Yeah.
So what is that? G over 2 minus G over negative 4 and change in X 2 minus 4, right? That is average rate of change, AROC. Sometimes we said AROC.
Yeah.
Okay. What is the value of this one? Can you find this one first?
Plug in the 2, plug in the... So we get 6 in the denominator?
Yeah. And we're gonna find the G over 2 minus the F over negative 4, right? Yeah. What is the G over 2?
6 in the denominator, and then G of 2 we plug in.
G over 2 we did already over here, right? G over 2 means what? G over 2 means what? G of x is here. 0 to 2 ft dt, isn't it? When you talk about f2 dt over here, plus, positive, minus areas is gonna be 0, right? G over 2 is 0, this one. Is it okay?
Yeah.
F of negative 4. This is the f of x graph. Negative 4, where is it? Negative 4, still 0 over here, right?
Yeah.
This is the graph of f of x. So f of negative 4 still 0. This is also 0. Oops. It can be. Let's see. F prime negative 4. No. F of negative 4, right? Oh. How we got this? G prime 2 minus G prime negative 4, okay? I'm sorry. G negative 4, okay? G over 2 minus G over negative 4. Okay, G over negative 4 is how much? G over negative 4 here. G over 2 is 0. We know that G over negative 4 is, what is that? From 0 to negative 4, right? Ft dt, isn't it? Put this number negative 4 there. X is negative 4. This is negative 4, right? So negative 4 on this graph. Are you okay with this?
Yeah.
So we're going to take integral from 0 to the left-hand side. 0 to negative side this way. We're going to go back the other side. This is positive. When you go back integral to the left side, that is a negative number, okay? Or you can switch this one. negative 4 and 0 switches, so that is a negative number, okay? Same thing. So now let's find the area of this one. What is the area? This area is how much over here? This is 2 times 6. 2 times 6 divided by 2 is 6.
12, 6 again. Yeah.
What is the area of this one? 2 times 4 is 8. So 6 plus 8, everybody, okay?
14. Yeah.
Yeah, 14, and then we have another triangle. 2 times 2 divided by 2, right?
Yeah.
Plus 2. Total is 16. So this number is a negative 16. Are you okay with this?
Yeah.
So numerator is what? 0 minus negative 16 over 2 minus minus is 6. So 16 over 6 is what? 8 over 3, right? Okay? All right. That is the average rate of change, okay? We just got over here, okay? That is the AROC, okay? Does mean value theorem guarantee the value, but there is at least C there?
Yeah.
Okay? For which what G prime C equal to this average rate of change. So G over here. If this is G, probably a 2 point over here, okay? One is negative 4, the other is 2 over here. We have a graph over here. This is the average rate of change is what slope of this line is 8 over 3. So is there any value of C there which has same value, same slope of your parallel, right? Yeah. This is the mean value theorem, isn't it? At this times, G is what is that? Differentiable, right?
Yeah. Okay.
G is differentiable, that's okay. If this G is differentiable, how to think? It's differentiable, right? Because your derivative already given over here.
Yes.
Are you okay with this? From 0 to, okay, from 0 to negative 4 to only. Negative 4 to, they are all what derivative that are available, right? Any derivative, they have the numbers. So this is what differentiable from the graph, okay? From the graph, G prime is G of X is differentiable.
Yeah.
Now we can apply, okay, it is differentiable, okay? We can see that from the graph. There exists a C, okay, a value of C, there exists a C such that this is average, okay? So when you take like G prime, okay? G prime C is equals to this slope, okay?
Yes.
C is what? This is slope of tangent, this is what? G prime C, isn't it? At some value. We don't have to find the C of it, okay? We just apply the mean value theorem, okay? So we can use mean value theorem or not, because this is differentiable, right? From negative 4 and 2 over here, they all have a differentiable value, okay? Derivative. G prime is over here, right? That's continuous, isn't it?
Yeah.
Okay? All the continuous. So this is differentiable, okay? So we can say that, yeah, we can guarantee because G of X is differentiable, okay? There must be just a C such that G prime C equals what slope of this line secant, okay? 8 over 3. Number 5. Consider the function y equal f of x whose curve is given by the equation 2y squared minus 6 equals to y sine x.
Yeah.
Or y equals greater than 0. Show that dy dx, that is derivative, that is equals to y cosine x over 4y minus sine x. We take derivative, right, to show this one. because it's impossible to express y in terms of x, right? That's why we have to use what? Implicit differentiation, okay?
Mhm.
2y derivative is what? 4y and the dy dt, okay?
Yeah.
dy dx. Constant 6 is derivative is 0. This is what? Product of two functions. First is y prime is dy dx and times sine x. Second one is y don't touch. Take derivative of sine x is a cosine x. That's right. We have a dy dx in the both sides. Here dy dx. Here dy dx. Okay, move this one to the left. This one, okay, move to the left. So we got this one 4y dy dx. I'm gonna write this as first. Minus sine x dy dx, that is equal to y cosine x. Now we have two dy dx, we need a common, right? We need to combine these two. So dy dx is out. Inside the parentheses, we got 4y minus sine x equals y cosine x, okay? After that, now you got only one dy dx. You can divide this to both sides. Okay, this one dividable here, 4y minus sine x. So dy dx equals exactly equal this one. Okay, we can show that y cosine x over 4y minus sine x. Number A is okay, right?
Yeah.
B. Write an equation for the line tangent to the curve at x equals, we have a point over here, 0 and 0.3. At this point, we're gonna find, okay, the equation of line tangent. We need the slope. It's okay? Where is the slope? We have already got derivative over here. That's the slope. dy dx is given over here. Y cosine x and 4y minus sine x. By this time, slopes need both two numbers, x and y together. X is 0, y equals square root 3, okay? Put this number. Because dy dx is in terms of x and y, okay?
Okay.
So y is square root 3, x equals 0, cosine 0. Y equals square root 3, 4 square root 3, x equals sine 0. Cosine 0 is 1. Sine 0 is 0, okay? Cosine 0 is 1 is 0, square root 3. Sine 0 is 0, that's 4 square root 3 minus 0, that's a 4 red 3, which is 1/4. That's the slope. So we got the point and a slope. The equation of a line tangent, y minus y1, slope times x minus 0, that's it. You can leave it this way, or y equals 1 over x plus square root 3 is okay too.
Yeah.
Okay, right? Right. The next number C. When x is 0 to pi,
Yeah. Oh.
and y is a positive.
Mm.
Yeah, only in these intervals, y is a positive, find coordinate of the point where the line tangent to the curve is horizontal. Horizontal derivative is 0, right?
Yeah.
On this interval, x is 0 to pi and y is 0. It satisfies these two conditions. Derivative is 0. Okay, tangent line is horizontal means what? Derivative is 0 over here, isn't it? We're gonna find this one. Y cosine x, that is dy dx. I'm gonna do what? That is derivative. and 4y minus sin x 0, right?
Yeah.
So we're going to find the value of y, x and y. This one cannot be 0. If this is an undefined one, okay? So y cosine x numerator must be 0. Are you okay with this?
Yeah.
But when you find the value of x and y can be denominator 0, okay? So over here, if y equals 0, take 0. Y is not 0, y is positive. This cannot be 0. Only this one should be 0, right? Cosine x equals 0. Are you okay with this?
Yeah.
Well, cosine x is x equals 0 and pi. Where is your cosine x equals 0? Cosine x equals pi over 2, isn't it?
Yeah.
Cosine 0 is 1. Cosine 1 is negative 1.
3 pi over 2.
Yeah, x equals pi over 2, that is 0, right?
Yeah, 3 pi over 2.
Yeah. Now we're going to find the y coordinate or point. When x equals pi over 2, what is the value of y? We find the value of y too.
Yeah.
Where we find the value of y? I think we need to find the value of y too, right?
Yeah.
This is already over here, okay? Put this number x is pi over 2 in the x in there, you can find the value of y. That's the equation, okay? So 2y squared minus 6 y times sine pi over 2. Okay, x is a pi over 2. Sine pi over 2 is 1. We got the 1 over here. So we got the equation over here. 2y squared minus y and minus 6 equals 0, okay? That's the equations. So we're going to factor this one, okay? 2y and y. Okay, to have this one, this is minus 2, this is plus 3, isn't it? So positive 3y, negative 4y, minus y, right? That is equal to 0. So y equals 2. The other is y equals negative 3 over 2. But y cannot be negative.
Yeah.
Is it okay? Y should be positive, right? So we take only y is 2, isn't it? So when x is a pi over 2, y is 2, right? That's the point. That's the answer, okay?
Yeah.
At this point, it has what? Horizontal line, okay?
Yeah.
The number D there. Determine whether f has a relative maximum and the relative minimum and maximum or neither at point found in part C. Okay? Just by your answers. So that we just find the point over here. At this point, pi over 2 and 2. At this point, it has what? Relative maximum, minimum, or neither.
Let's look at the. Have to be relative maximum.
Okay, so we check out the dy dx first, okay? At this point, pi over 2 and 2, right? dy dx first. Put this number there. Y is 2. X is what? Pi over 2. Y is 2. 4 times 2 is 8. And minus sine pi over 2.
Yeah.
Okay. So what is this one? Cosine pi over 2 is what? 0, isn't it?
Yeah.
This is any numbers. This is what? 8 minus this is 1 over 7. Dy dx equals 0, right? At this point.
Yeah.
It's okay? Yeah, that's fine. But this one is what? 0. We don't have any information of it. That is a relative maximum or minimum. We don't know. two possible. Zero is what here. Or it can be a relative minimum, zero, right? Or sometimes this one. This is also zero, isn't it? This is neither. It does not let the maximum or minimum. Are you okay with this? Right, when you have a zero B, we have these three different cases. Case 1, relative maximum. Case 2, relative minimum. Third one, it looks like this one. That is still fx derivative is zero, right? Still, this is a critical point. Are you okay with this?
Yeah.
F of prime is zero, x equals zero means we said at this point, x is we said critical point. You have three different critical points, okay? Case 2 and the case 3, right? They are all is called by critical point. Their slope is all what? Horizontal, okay?
Yeah.
So how can you check out? Or we can check out what second derivative, is okay? Second derivative is a positive means a concave up. This case, this is concave up, right?
Yeah.
At this time, relative minimum. This time, concave down over here. At this time, relative maximum. This is nothing. We check out the second derivative, okay? Oh, this is a little hard. dy dx. Take a derivative one more time, okay? D square y dx square, okay? That's the second derivative. We take this one. dx dy dx, okay?
Yeah.
This is what? D square y over dx square, okay?
Yeah.
Wow, this is a lot of work. Okay, denominator square, okay? 4y minus sine x squared. The numerator derivative, how much? First derivative, y derivative is dy dx and times cosine x. And after that, we multiply, this is a little hard. Too much, this is too much.
Yeah.
Okay, anyway, the derivative of this one is y equal cosine x, and y times cosine x derivative is negative sine x, okay? So it's gonna be negative y sine x. After that, you multiply the denominator, okay? 4y minus sine x. After that, minus first one don't touch. After that, take right derivative of denominator, okay? For y prime and the derivative of sine x is cosine x. Okay?
Yeah.
But we know that dy dx is 0 over here, right? At this point. So this is dy dx, that is 0. dy dx, this is 0. Are you okay with this? Now put this number pi over 2 and 2 in there. Sine pi over 2, cosine is what? Cosine pi over 2, they are all 0, right? Because the cosine pi over 2 all 0, isn't it? But this is all going to 0. Are you okay with this? Now the only things over here, y sine x, 4y sine x, okay? So y is 2, negative 2, sine pi over 2 is 1, times 4 times 2, y is 2 is 8, minus sine pi over 2 still 1, all 0, over 4 times 2 is y, 8, minus sine pi over 2 still 1, and square, right? This is 1, this is 1. So negative 2 times 8 minus 1 is 7, over 7 squared is 49. That is a negative 14 over 49. That is a negative number. Negative means a concave down, isn't it?
Yeah.
Okay, concave down is what this time. Concave down at this point. So actually this one is what? Relative maximum. Are you okay with this?
Yeah.
Right, it has a relative maximum, okay, at this point, okay? Because our second derivative is less than 0, okay?
Yeah.
You have to show this one. Well, this one a little hard, okay? Number D. Okay, I'm going to send out the link to you, okay? So You just figure out, okay, as much as you can, okay?
I will.
But actually, I know, right? You don't have to solve every questions, okay? But each question is first two, okay? If you can do that, just the first two is enough. Okay, anyway, you get to a 0.5. Okay?
Okay.
All right. So focus just 0.2 and try get the next two again, okay?
Yeah.
All right. So I'm gonna